Well, it's already recording. So
Okay.
as soon as Dr. Russ says go, you go.
It's all of it. Okay, I'm gonna reflect on it. When does your time start?
Whenever you start.
Okay. Okay, so our lesson today is balanced chemical equations and the law of conservation of mass. You guys have been exposed to chemical equations, and you know what they are, but today we're going to learn whether they're balanced or not. So what you already know, all matter is made up of atoms. All matter has mass. Atoms are made of protons, neutrons, and electrons, positive, neutral, and negative charges. And every substance has its own chemical formula. So like the chemical formula for water is H2O, and that we went over. And the H2O is pretty much, it's almost like a recipe for that substance. So for water, you need 2 hydrogens and 1 oxygen. Then we have the subscripts. You guys are briefly exposed to that. So 1 molecule of water has 2 atoms of hydrogen, so that's what that 2 means. And all chemical equations tell you what it is that's happening in a reaction. So what's new? Okay, so here we go with subscripts again. So we have the little 2 down here. That means there's 2 hydrogen atoms in 1 molecule of H2O. We have coefficients now. Do you know what coefficients are? Yeah? Yes?
I know that co means with or next to.
Yes, exactly. So with H2O, there's no coefficient here, so that just means there's 1 molecule of H2O. Here we have 2 molecules, the 2 in the front, so there's 2 whole molecules of water. So the coefficients can be changed to balance the chemical equations, but the subscripts, what do you know about the subscripts? Can they be changed? When can they be changed? Never. That's enough. They can never be changed to balance the reaction, or the chemical equation. So, 2 H2Os. How many water molecules are right there, Bowie?
2.
2. Good. How many hydrogen atoms are there total? Bowie. Felix.
4.
4. Why, Ryan?
Why? Well, there's 2 hydrogens with the subscript, and you also have to counter in the 2 for the coefficient. So you multiply those.
Right. So, 2 in the water molecule, or 2 for every water molecule, and there's 2 water molecules. 2 times 2 equals 4. How many oxygen atoms are there, Bess?
2.
2. Good. Okay, so for an activity, we have a starburst activity. Yes, get excited. It's a ton of fun. But we have some rules. You do not open the bags until I tell you, and you don't eat them unless I tell you you can. And you get to eat them if you participate. So, here we go. So you have 3 different colors in here. Right now, for the first worksheet on the front of your packet, we're going to only use the maroon and the orange. So don't even pull out the blue yet. Pass that one back to Layla and George. That one's for y'all. And one for you. Okay. So, exercise 1, you should have out right now. And so the key to this is hydrogens are going to be your maroon starbursts, and your orange starbursts are going to be your oxygen. Good? Okay. So, underneath every one of the reactions, I want you to put the correct amount of maroon under the hydrogens and the correct amount of orange under the oxygens. So you should go ahead and open those up now.
That's a team effort.
Shoulder partners. Collaborative.
So we
Oh, so we're just
2 hydrogens.
stating the total?
2 oxygens.
There's a reactant
And the
or
products.
Okay.
And only 1 oxygen. So it's not balanced.
What did you say, Layla?
It isn't balanced.
How do you know?
Because there's only 2 oranges on the left side and there's 1 orange on the right side.
That is right. So your paper should look a little something like this. So is it balanced, class?
No.
No, it's not. How do we balance it? With coefficients. Good, Brandy. So flip that one paper over, and you should have another exercise behind that. So go ahead and fill in that number, that magical number that you think is going to balance out your reaction. And stack up your little starburst underneath there.
O is orange.
Right. All done? Eyes on me when you're done? Yeah?
Oh, yeah.
Okay, so you should have gotten 2s on each side, and it should look a little something like this, more or less, just number-wise. Is this equation balanced, class?
Yes.
Yes. Yes. Okay, so a little bit harder. Flip over to exercise 2, and now you can pull out your pretty blue starbursts and use those. Now remember how we multiply coefficients and how we multiply the subscripts and what that means. And go ahead and stack those over there. Now the C's are going to be the blue, like the carbons are going to be your blue starbursts. So go ahead and start thinking. Eyes on me when you're confident. Good. Okay. So, how many carbons are on each side? 1. 1 and 1. What are those? Your hydrogen. Okay, and what's the last one? Oxygen. So you should have gotten something like that. Do you have all 4 of your oxygens and the same 4 on the other side? Good. Do you, Ryan?
What? I didn't understand the
Do
question.
you have the same amount of
Yes, we do.
orange on each side?
Mm-hmm.
The same amount of maroon?
Yes,
And
we
blue?
do.
Okay, so what does that tell you?
The equation is balanced.
Equation balance. What did you find? Okay, balancing equations. So we have this scale. It represents your product side and your reactant side. You have your pretty equation that you already did with the with the water. And then you have your 4 hydrogens, and your 2 oxygens on each side. So it's balanced. We have the same number on each side. Why? Why do we have to balance chemical equations? Beth, you know?
Law of conservation.
Because it's the law. And you're right. Which law, Dr. West? The law of conservation of mass. Good. Good, Beth. Okay. The law of conservation of mass states that matter cannot be created nor destroyed, it can only be rearranged. So, that's what we have here on your equations. You have the same number of hydrogens as on the other side. You didn't add any extra into it, you didn't take anything out. So, mass is conserved through the chemical reaction it goes through. So we can relate this back to cake. We have some mix, so that's like a compound. It has a lot of stuff already into it. We have some eggs, and we have some oil. Now, what do you get when you put all of those in and you bake them? It goes through like a chemical reaction. You get pretty cake. So you didn't add anything else to it, you didn't take anything out, it reacted, and now you have cake. That's the same thing as the tough little equation you just bashed because you knocked it out of the park.